Okay, guys, listen, please. The next topic that we're going to begin is called linear equations. Yes, we've been solving equations. We've been solving inequalities. We've even done absolute value inequations and compound inequalities. You guys have done a terrific job with them. So I'm going to try to relate a linear equation with what we've done already to make sense of it. Remember, it's kind of like a job for us. We have to know the math language. We have to make sense of this. So please, there's not going to be an assignment necessarily attached to this video, but you need these notes because this is what's going to explain to you what in the world is a linear equation. Okay, and a linear equation is also attached to a linear function. So what does it mean to us? Now, if you will please write this down, says 4x plus 3. And this is the first thing I'm going to tell you about a linear equation. There's a couple new things you're going to see. There's a couple old things you're going to see. The old thing that you're going to see, is this. I hope you recognize this as being the simplified version of an equation. We simplified this side, then we simplified this side. Then after we simplified them by doing the distributive property or combining like terms, then we used our properties of equality. Yes, it all goes back to that. But now we're going to simplify this a little bit more. This is a simplified version. We've got one variable with a coefficient, and we've got a constant. And because of that, this is called a linear equation. Well, this isn't really a linear equation right now. This is an expression because we don't have an equal sign yet. So here comes the new stuff. What's new for you is we're going to put an equal sign in front of this. We're going to put a y over here. So now we have two variables. So anytime you have two variables, that's called an input and an output. We're going to put something in for x. We're going to get something out for y. Why is this linear? There's two reasons it's linear. And eventually I'm going to turn on my projector here, so I might get blown up with light a little bit. But there's two reasons for this linear. Number one, it draws a straight line. So graphically and visually, we can see a straight line. But what it really is in real life is it's just something that's changing constantly. It is a constant change. You'll see what we mean by that. So it has two meanings in algebra. Number one is it's going to draw a straight line. Number two is it's something that is changing at a constant rate. That means it is linear. So here are the parts of a linear equation that you have to understand. This, positive 3, is what we call the y-intercept. And you may not know what these things are right now. You may not know what they mean yet, but you will here in a few minutes. The y-intercept in real life is always where you begin or where you start. However you like to say it is fine. Remember, we're all different in math. The y-intercept is where you begin. It's the algebraic way to say, where am I going to start something? This 4 is your rate of change. Okay, this rate of change means, well, exactly what rate of change means. It means how much is something changing. But that rate of change has an algebraic term too. It is called slope. So the algebraic form of this is slope. I know I put the y-intercept up here and the slope down here. One's in parentheses, one's not, but you get the drift. So this is your algebraic one. This is kind of like the modern day English of what in the world this means. This is how fast something is changing. This is where something is beginning. The x is your input. That means I can put something in, whatever number I want, and when I put that number in, my y is going to give me my output. Now, in order to recognize a linear equation very quickly, or any type of linear equation, we'll always have one of two things. When you look at the variables, okay, if the variable has an exponent of 1 or 0, that means it's linear. So you can recognize it really fast. This x right here actually has an exponent attached to it. It's just hidden. We know there's one x there, so therefore it's to the first power. Let's say I have this. x squared. Well, x squared is not to the power of 1 or 0. So x squared is not going to be a linear function. So if you ever see a linear equation or a linear function that has x squared with it, that's a big no-no. That means it's nonlinear. It's not going to create a straight line. It's going to go curvy. And we'll explain that later on. Right now, linear equations. So what does this mean for us in algebra now? Well, you have to make sure you know this is where you start. This is your rate of change. Our rate of change, this number right here, we always want to be a fraction. And you may say, well, Mr. Zernick, 4 is not a fraction. 4 can be a fraction. 4 is a fraction if you write it like this. Very important, because slope is developed with two things. This one on the top is called a rise, and this one on the bottom is called a run. It is rise over run. Sometimes we get these nice fractions and we don't even have to put a 4 over a 1. Maybe it's 1/2. Well, 1 means we go up 1 and we run 2. We rise 1, run 2. So what in the world does all this mean? What are you telling me here? Okay, please watch this. As my screen is going to pop on here and I'm going to get blinded by the light, we are going to graph y equals 4x plus 3. Now, when we graph y equals 4x plus 3, we're going to do exactly what we kind of told you here in English. We're going to begin on our graph paper at the y-intercept. That is where it crosses the y-axis. So here is my graph paper. There's my x-axis. There's my y-axis. Now, I know you can't see the graph paper extremely well here, but I am going to begin on the y-axis at the number positive 3, which means I start at 0, 0, and go up 1, 2, 3, and I put a dot right there. Now, when we're talking about the slope, if the slope is positive, positive always increases from left to right. So positive slope always goes up. A negative slope will always run down. So why do I keep that in my brain? I keep that in my brain so, again, as soon as I look at this linear equation, I know it's got a positive slope. I know it's going to go up because the number 4 was positive. So now I got to use my rise over my run. My beginning point, my starting point was my y-intercept. It's right there. I'm going to go over to that y-intercept. I'm going to rise 4, and I'm going to run 1. And I'm going to make sure if I connect those two dots that it is increasing. It is an increasing or positive slope. So I'm going to rise 4, 1, 2, 3, 4, and I'm going to run 1 over to here. Now, sometimes, guys, this is called the slope triangle. Because once I get one point and I know that it's rise 4, run 1, I'm going to continue to rise 4 and run 1. I'm going to do it again. 1, 2, 3, 4, run 1. 1, 2, 3, 4, run 1. 1, 2, 3, 4, run 1. It's going to end up there. And then after I do that, I can do my best to connect all of these. I know that's not my perfectly straight line, but that's going to create a straight line. Well, what do we know about this straight line? Well, we know that something is increasing at a rate of change that is constant. It's a constant rate of change. It's constantly changing by the same thing. Why? There's an input-output table. If x is 0, and I put it in here, 4 times 0 is 0, 0 plus 3 is 3. Here's how it relates to your graph. 0, 3, graph is right there. That's where we started. If x is 1, 4 times 1 is 4. 4 plus 3 is 7. My output is 7. My next dot that I would have in this line is 1, 7. It's right there. I can continue. 2. 2 times 4 is 8. 8 plus 3 is 11. There it goes. Here it is. Bingo. It's changing at a constant rate. No matter what we put in there, we're going to get a nice line. We can make predictions for the future. Okay, if you start off with $200 in your bank account and you make $100 a day, well, at the 0 day, when you put it in, you had $200. And then you just keep putting in $100 every day. So your $100 you're putting in every day is your rate of change. So these linear equations, and I know I threw a lot at you with this linear equation stuff. These linear equations, you have to make sure you understand a few things before we even get started. Y-intercept, that's this part of it. It's not attached to the variable. Your slope or your rate of change, right there. It's how much something is changing. The X and the Y are determined by you. Whatever you put in for X, you'll get an output for Y. You put in another X, you'll get another output for Y. You're going to notice, though, that if you put it on a graph, it's going to draw you a perfectly straight line. It's linear. Okay, there's many linear things in our world. I stopped at the gas station last night. The gas costs $2.59 a gallon. If I buy 5 gallons, should I know how much I'm going to pay? You better believe it. Okay, you could figure out how much money you're going to spend before you get there. That's pretty smart for people that want to know money, right? A little bit of business. Make sure you understand this, guys. I'm sorry this video was so long. I normally don't do that, but this is very important stuff, and I hope you can kind of get the gist of all this. I'm going to continue with some little things on these linear equations that are going to help you out a little bit more than this might do. But again, this is our job. If you make mistakes, we don't care. Ask me. We'll clean it up. You'll know way more, I hope, when you leave than when you got here. Okay. This will be attached to your next lesson. This is your first topic and topic 2. And you're going to try some things. I'm going to put some other things on for your assignment, and I want you to just try them. You don't have to be a pro. Try them.